Welcome to this lecture on Zero Architecture Design. My name is Dr. Kyoung-Hee Kim, and I'm a professor of architecture and the director of the Integrated Design Research Lab at UNC Charlotte. Today, we will explore the Zero Architecture Design. Let's get started. In this module, we will cover three key topics. 1. Why zero architecture is important in today's built environment. 2. What are the key design framework focusing on zero energy, zero carbon, zero water, and zero waste? And 3. What are design strategies to meet the 4 zero design goals? By the end, you will have a clear understanding of zero design strategies and actionable insight for your architecture projects. This slide presents global CO2 projections under various policy scenarios, from the current policies indicated at the top in blue to more stringent requirements indicated at the bottom in green. According to the 2018 IPCC report, the current policies will fail to achieve a 1.5 degrees Celsius warming limit. Therefore, much more stringent policies are needed to meet this temperature limit. This requires reaching a 45% reduction in emissions by 2030 and 100% carbon neutrality by 2050. All sectors play a crucial role in reducing emissions and saving resources. This graph highlights the importance of legal commitments and stringent policies in driving the adoption of zero buildings. Here, we see the key three factors that cause environmental impact. Environmental impact, I, is the function of P, population, A, affluence or consumption per capita, and T, technology or resource utilization. As the population grows, environmental impacts naturally increase. Likewise, when consumption per capita increases, environmental impact increases, even if technology becomes more efficient. Some of you may feel T factor would mitigate the impact, but it often expedites rapid resource consumption through mass production, amplifying environmental impact. We should carefully evaluate the use of technology and aim to use technology to significantly reduce the overall impact. This equation reminds us that our design decisions, such as material selection, energy efficiency, and construction waste management, directly influence environmental impact. By 2050, 2 out of 3 people will reside in cities, and the global population is expected to grow by 2.2 billion. This requires 2 trillion square feet of new construction to accommodate the increasing urban populations. This is equivalent to constructing a brand new New York City every month for 35 years. This surging demand for urbanization emphasizes the need for zero buildings and cities to minimize the environmental footprint of the growth. The IEA's Net Zero by 2050 report outlines a roadmap to achieve the carbon neutrality goal by 2050. The graph here shows key players of the power sector, highlighted in blue at the bottom, industry, manufacturing sector in orange, transportation in purple, and buildings in green. For example, by 2030, all new buildings must be zero carbon ready, and 60% of global car sales must be electric vehicles. By 2050, more than 85% of both new and existing buildings must achieve zero carbon status, powered by renewable energy sources like solar and wind. Looking at global carbon goal progress, we see a range of countries at different stages of carbon neutrality commitments. For instance, the US is currently in policy document stage and aims the carbon neutrality by 2050, while China also is in policy document stage and target the carbon neutrality by 2060. In comparison, other European countries, South Korea and Japan, for example, incorporated carbon neutrality implementation into legal commitments and aim to meet the carbon neutrality by 2050. We must strive to meet these targets as soon as possible and advocate for law and policies that accelerate the carbon neutrality in the built environment. This slide illustrates the significant financial loss and social impacts from climate-related disasters. 152 climate disasters over a decade range from wildfire, flooding, drought, and sea level rise, causing $1.1 trillion losses. These disasters underscore climate urgency to reduce the anthropogenic impacts and the need for better prepared buildings and cities. Zero buildings can not only mitigate climate risks, but also reduce long-term cost and social burden. Zero design buildings aim to achieve four key goals: zero energy, zero carbon, zero water, and zero waste. Each goal requires specific strategies, from reducing energy consumption to promoting water recycling and minimizing waste generation. By addressing these goals holistically, we can create buildings that are not only efficient but also regenerative.